Another important phenomena in radioactivity is radioactive equilibrium. This is associated with the radioactive series only, which we have just now studied in the previous section. So here we can write in a radioactive series, which we have studied, that when an element decays to another, and if it is also radioactive, it decays to further and so on. It continues till the stable product appears. In this situation, successive decay constants would be there. Here in this situation, let us consider at any time instant t, say a number of nuclei of element A1 in the sample are N1, that of A2 are N2, that of A3 are N3, and so on. Now in this situation, at any instant we can write the production rate of a nuclei of element A2. This will be obviously disintegration rate of A1, because as A1 are disintegrating, they are decaying to A2. So production rate of any element can be written as disintegration rate of their previous element, that is A1 in this situation, and that is actually the activity of A1 at this instant, which is written as lambda 1 N1. As lambda 1 is the decay constant of element A1 with which it decays to A2, and N1 are the number of nuclei of A1 present at this instant. Similarly, if we talk about the disintegration rate of A2, that will be activity of A2, the rate at which the nuclei of A2 are decreasing. This can be written as lambda 2 N2, because at this instant N2 nuclei of A2 are present, and lambda 2 is the decay constant with which it is decaying to A3. So at this instant, the production rate of A2 is lambda 1 N1, and the decay rate of A2 is lambda 2 N2, with which it is decreasing. So here we can write, if these two rates become equal, then we can say the amount of nuclei of element A2 will appear to be a constant, because the rate at which it is being produced and the rate at which it is being disintegrated will be same. And that is the state we call radioactive equilibrium. So here we can write element A2 will be in radioactive equilibrium when its production rate and decay rate are equal, that is lambda 1 N1 is equals to lambda 2 N2, and under this state the amount of A2 appears to be a constant for some time till the activity changes. And we can also write, before this time lambda 1 N1 was more, lambda 2 N2 was less, so amount of A2 was increasing. And after this time, as N1 further decreases, so production rate of A2 decreases and the disintegration rate will increase. So this will go down. So the amount of A2 will be maximum when it is in radioactive equilibrium. This is the condition of radioactive equilibrium for the element A2. And here we can also write down a note that in radioactive equilibrium, the number of nuclei of element will be maximum, and it appears to be a constant for the duration the equilibrium will persist.